Welcome everyone. In today's lesson, we're going to start off with a familiar term, empirical formula. I've often called empirical formula the empirical form. And by definition, empirical formula is really the simplest ratio of atoms of each element. And ratio is really the key term. When we talk about empirical formula, we also have to talk about the molecular formula. Oftentimes when we see the word molecular, we have to think about covalent substances. But in this case, when we compare empirical to molecular formulas, we use it a little bit more generally. By definition, the molecular formula is the exact number of atoms of each element. And the key term here really is exact. Empirical implies the ratio, really the simplest ratio. When we talk about molecular in a general sense, it's really the exact number. Now, the empirical formula and the molecular formula are connected specifically by a factor. Really, what we say is that the empirical formula times a factor will give us the molecular formula. So if we have the empirical formula of C3H2, we can multiply by any factor. And that factor is always a whole number. So I can easily multiply it by a factor of 1. When I multiply by a factor of 1, my molecular formula now becomes C3H2. And it is possible to have an empirical formula that is exactly the same as the molecular formula because they are related to one another by a factor of 1. But we can have other factors as well. If we take the same empirical formula and multiply now by a factor of 2, my molecular formula now becomes C6H4. Every subscript gets multiplied by a factor of 2. If I wanted to even go higher, I can even go to a factor of 5. So when I take this empirical formula and multiply by a factor of 5, I'm going to take each of the subscripts and multiply by 5. So my molecular formula ends up being C15, and now it's going to be H10. Now, because there are so many possible factors, we now have to learn a new skill. And the skill that we're going to learn is really how to find the molecular formula when given the empirical formula. In order to carry out this skill, I've come up with a shortcut. The shortcut really is Mo finds the factor. And I use Mo as a name, but Mo really stands for molecular over empirical. But Mo will help us find the factor that relates the molecular formula to the empirical formula. All right, so let's take a look at a sample problem. The sample problem reads, a compound has an empirical formula of CH2 and a molecular mass of 56 atomic mass units. What is the compound's molecular formula? So once again, the skill is really finding the molecular formula. That's really what we need to do. And we are given the empirical formula. Now to organize you and also myself, I tend to kind of make a little chart for myself. And I think when I read this kind of problem, I have to remember that Mo finds the factor. So I'm going to keep it as molecular over, literally over, empirical. And I make this chart for myself, and you don't have to do it, it's not a requirement, just to kind of organize what's in the problem. Now the problem says, what is the compound's molecular formula? That's what the question says. So my unknown is right here. I don't know the molecular formula. That's what I have to find. So I'm going to make it an X. But there are several things that are given to me in the problem that I can use. They definitely give me the empirical formula. If you noticed, it's right here. So I'm just going to place that here, CH2, and that's already given. When I continue reading, I also see that the molecular mass is 56 atomic mass units. So I can place that here, 56 atomic mass units, and that was given already. Now I still have one more thing to finish, and I have to realize that I can easily calculate the empirical mass. When I want to find the empirical mass, all I really have to do is I just am taking formula mass. And I need to find the formula mass of CH2. So I'm going to do as I always do. I know that I have one carbon, and I'm going to multiply it by 12.01. And remember, when you take the masses off the periodic table, take it to 2 decimal places without rounding. That's important. I also notice that in my empirical formula, I have 2 hydrogens, and according to my periodic table, that's going to be a mass of 1. When I do this correctly, multiply across and then add going down, I now have 14.01, and the unit happens to be atomic mass unit. So that's something I actually have to calculate, but I can put it into my table once I calculate it. And the table reminds me that I need to calculate it because I have this open space. I can only have one variable, and that's where my x happens to be. So in some of these problems, you're going to have to actually calculate the the mass of the empirical formula. Now, we're not even done. The shortcut was mole finds the factor. So mole, molecular, over empirical, is what we're going to do mathematically. I'm going to take the molecular mass of 56 atomic mass units, and I'm going to divide it by the empirical mass, which I calculated, of 14.01 atomic mass units. When I solve for this mathematically, I end up getting a number of 3.997144 and a whole bunch of other decimal places. Now, you should know that when I calculate the factor using mole finds the factor, it must be a whole number without any decimals. So I'm going to have to round this. 3.997144 with a whole bunch of other decimals rounds to approximately 4. And that 4 ends up becoming my factor. So mole found the factor. Now I'm not done because I don't want to know the factor. The question asks, what is the compound's molecular formula? So now I'm going to take the empirical formula of CH2. I'm going to multiply by that factor of 4 that I calculated, and I'm going to get my answer. So now I have to take each subscript and multiply by a factor of 4. I end up getting C4H8, and that's my answer. That's the molecular formula that comes from giving me this information. So I don't want the factor, I don't want the mass of the empirical formula. I want the actual molecular formula with the numbers, with the symbols, with the subscripts. All right, so that's what you're looking for. All right, you're going to try a few on your own, and I'll see you in the next lesson. Bye for now.